Planning for uncertainty. Last year I had a talk about history of management so that I could better explain self-organization in organizational reality. And I was very inspired by the work of people like Ralph Stacey, especially work of Ralph Stacey. So I really studied carefully his books and still studying them because they are kind of difficult to me. And because I have to deal with management very frequently, when I have trainings or when I coach, I have to talk with manager. I never been a manager, I never wanted to be a manager, and most probably never will be a manager, but I had to learn things so that they can understand better why I'm saying bad things about them, to them, basically. Yeah, and I must say that complexity, chaos theory, and all those things that are very frequently around Agile, about Scrum. If you remember, one-liner from Scrum would be Scrum is a complex, is an empirical process framework for delivery of complex products. So we see this complex. Complexity happens to be mentioned very frequently in many contexts. Yeah? And planning will be around this area because it seems to me that even though we adopted a number of practices, especially from extreme programming, I think everyone in the world knows what planning poker is, of estimation poker. Like the same, everyone in the world knows what daily Scrum is. If you go to the street and ask any first person on the street, how long should daily Scrum take, everyone will say 15 minutes. It's like everyone knows that. As the same happens probably with planning poker. So we all, engineers, managers, product owners, Scrum Masters, who kind of enjoy this new kind of cool toy that we were given. But our planning in the end, how we finance the products, how we finance our work remains pretty much the same. And to some extent, I want to deal with those problems here, this talk. I want to first, though, bring a little bit of the context. Not too far, because it's about complexity. I must be honest with you, it's kind of challenging to me. Complexity and chaos seem to be still kind of disputable areas when people still tend to disagree what they really mean. And additionally, if you really want to really understand what is complexity, what is chaos, especially from mathematical point of view, you would have to be a pretty good mathematician. I'm not anymore. I think forgetting how to compute the integral already. So it's getting harder and harder for me to follow that. But I want to give you some kind of thoughts and set in context so we all see why I will be saying things a bit later in this talk. And so, did you know actually, it was some time ago, it was to me kind of surprising. Did you know that chaos is actually deterministic? It was kind of for me like the same kind of surprise when I learned first time that Ford Mustang is delivered by the same company that creates Ford car. I couldn't imagine the company that makes Ford Mustang could create such a crap like Ford car, for instance. It was for me a big surprise, but it was the same from chaos theory. How chaos can be deterministic. Yeah? It was actually 100 years ago a very last great mathematician who mastered all disciplines in mathematics. It was the last great one, I would say, that people sometimes refer to him. Henry Poincaré, I think that would be kind of pronunciation. He, when working on three-body problem about orbital movements, which tend to be kind of difficult to compute trajectories and other things, he coined and kind of became a father of chaos theory, but chaotic deterministic systems. Yeah. Still, chaotic deterministic systems, as he used to say, they are predictable in the short term, but they still say in the long term, well, yeah, it's like, you know this famous butterfly effect. When butterfly moves the wings, there's a tornado, hurricane on another continent. This is kind of chaos, but for practical reason, we cannot trace those things. It's just, in long term, we can't do anything about it. But chaos theory evolved. It became better, bigger, and another famous person that I actually mentioned last year here, Ilya Prigozhin, who is a very famous from his nice book, The End of Uncertainty. The End of Certainty. Pretty important stuff. He says that complexity per se is totally non-deterministic. And there's no way whatsoever to precisely predict the future. And as I said, for me, the difference between chaos theory and complexity seem to be pretty difficult to grasp in depth. But if you look at those kind of sentences, like chaotic behavior pushes system in equilibrium into chaotic order, which means, in other words, out of what we traditionally define as order, I can kind of follow that. It's not very difficult, but I will show you just in a while Stacy diagram, and then the chaos seem to be something a bit different. Frequently, when we think about chaos, we mean amount of complexity we cannot deal with anymore. That's what we intend, like kind of common sense thinking. Such enormous complexity that it becomes destructive. The system stops to be a system. Yeah. But here it looks to be kind of a bit different. You can take a look also at this one. Chaotic behavior in the sense of deterministic chaos is the result of a relatively small number of non-linear interactions. Yeah? The only thing that I could capture from this, I really make a picture from, is that when we talk about chaos, we don't really, in most of the cases, look at a huge number of agents. When we talk about complexity, we focus more on interactions between huge number of agents. And those interactions is kind of, as Ralph Stacey is saying, those interactions are the fundamentals of self-organization. And that was the talk I had last year here. So again, what is in common for chaos and complexity could be kind of the same thing, is that they both cannot be predicted in long term. In the end, that's our kind of attachment point. If this is not true, then this whole agile crap wouldn't mean anything. Yeah? It's like saying if Jesus didn't resurrected, Catholicism doesn't make any sense. It's the same for us. It's our kind of religion, let's say, but this is fundamentals. If complexity is not what it says, then we wouldn't have to do what we're doing. So that's attachment point. And Ralph Stacey draws a nice diagram. I'm pretty sure many people saw that because the same kind of simplified maybe version of this diagram is used in the first book on Scrum from Mike Beadle and Ken Schwaber, I think, was also author of this one. And you see here that the world is nicely divided into simple, complicated area when we say systems are in equilibrium, which means they're going to die, basically. There's no innovation, no progress, no anything. And the further we go to the right and to the top, things become sneaky and become more challenging, complex, and we sometimes say unpredictable, harder to find out what will happen. Yeah? And what is nice here, though, I want to just, at this point, you see this creativity field, this green field. It's something that is kind of an area in the research is also formally recognized as the area between mathematical chaos and complexity. It's at the edge of chaos, kind of very popular term, but it's kind of hard to explain sometimes what does it mean. I think what people learn from that is that if you want to be creative, you have to reach towards chaos, basically. You have to balance on the edge, sometimes what people say. Another thing that we realized, the organizational reality is that members of the organization are not rule-following entities. People do not follow the rules. They're ugly beasts sometimes. Yeah, they are source of all success, but also ultimate source of every failure. They mess things and they make beautiful things. Yeah? That's from the last year. Self-organization per se, the one that we want, the self-organization of reasonable entities, not plants and potatoes, but people. We want it to be unexpected. Yeah? And it can be constructive and it can be destructive. Yeah? That's the important thing from here. People do not follow the rules, and therefore, thanks to that, they can be creative. It follows actually something very old from Kant times, saying that you cannot really build system built from people because people are so much special. They're not like potato growing in a very predictable way that you can actually plan it. Which means every time we move, we add people to any problem we have. And that will be planning, our daily job of estimating anything that we do, adding people to it. human factor makes things more complex than they really are sometimes. To summarize, this is just setting the context, so now I'm moving to my kind of major topics. Many people can influence things, many influencers, but nobody in control. Nobody knows the outcome. That's reality. And in my couple of years of being in a number of companies, I never really saw any management embracing that. People still panically. It's kind of trauma. They need to feel they are in control. It's very hard to remove, and estimation is one of the things that it's very easy for them to put their hands on and really start messing with everything based on that. The question would be, is your estimating in planning, for instance, in your organization kind of aligned with reality, therefore? Is it a response to the fact that nobody knows? That people may kind of have very good intentions, influence things, try to be best developers, but they don't know what will happen because interactions between them are so complex. If you look at estimation in Wikipedia, you'll see a quite interesting thing. What matters in the screen is really the first sentence. Accurate estimates are the basis of sound project planning. Yeah? You see how heavy weight is added to it. When you look further, popular estimation processes for software projects include blah, 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 and we see planning poker, hooray, we are at home, and planning game, kind of things that we are kind of aware of, but you see they mix those new estimation techniques or engineering practices even with something that was there already, old things. They mix old philosophy with new philosophy as they just belong to kind of the same group. That's the same problem we observe in many organizations. When people adopt agility, they think it's just switching from a rational unified process to Prince2. It's not. And especially if we stop at planning poker, that's a nice example. If you remember planning poker, those people, the first thing they tried to convince everyone to, and when you read an extreme programming book like Embrace the Change and great book from Mike Cohn on Agile, estimating and planning, the first thing they want to convince you is to stop estimating in time. Yeah? They keep it kind of this, numbers, no units. Yeah? Why? Because, well, it's pretty easy. You can get quickly over that because it's estimating in time is like asking a runner, how much time do you need to run 100 meters? Yeah? It depends. This guy is pretty fast. Yeah, I'm not. Yeah? And on the given day, he may win gold and break the world record. On another day, not. You see, that's the tricky thing that happens. If you have to dig a hole in the earth, one by one, dig your own grave, for instance, yeah? You know how big it's supposed to be, but how fast can you do that? Yeah? Depends on the tools, again, another factor, depending if you're a digger, professional digger, or just a shovel. And then add to this lazy people, or unpredictable people, maybe creative people. Yeah? And things can go much better or much worse. Shortly, estimating the time was kind of stigmatized because it has a number of assumptions that are very hard to control. There are hidden factors that you have to deal with and you cannot influence them. Yeah? Like, exactly speaking, who will be doing the job? What will be the guy productivity level at that day? Yeah, will be the team still in the same shape? Or everyone will think about each other, you are an asshole. Yeah, and that doesn't work anymore so good. Yeah? So many factors. Another thing that when introducing planning poker from extreme programming, when you manage to somehow think, let's try forget about time for a while, then you are put in a kind of another abstract thing. What is an estimate? What is really the size? They want you to size think. What really size is? Yeah? And size is an effort, complexity, risk involved. Can be a number of things. Can be actually kind of combination of the three. And everyone, I think it has a spelling mistake, that would be WW risk. And everyone in the team, when you ask about size of something, everyone in the team will have different weight. And estimation poker, that's the case. Estimation poker was brought not actually to find out the actual size. It's irrelevant. Estimation poker was brought to be a kind of protocol setting tool. Yeah? It was about to balance the weights and make sure that in the end you get a team estimate. It takes time. Yeah? It also, from that point, you could see how important it is to keep fixed, stable team for a long time. You cannot just shuffle them because otherwise team estimate is gone. But estimation poker, it's important, it's not about concrete estimate, it's about protocol setup. It's about understanding what size means to us as development team. It's therefore a great communication tool, reveals the differences, that's pretty standard, but additionally helps realizing and removing fluctuations. By communicating, looking at during refinement sessions of the product backlog, we may find out that our ready to be taken items to sprint are still of different sizes, for instance. And in any good lean process, you will try to remove fluctuations. Could we do the same thing with estimation poker and still play with time? If it works for sizes, no, the question is kind of obvious. No, because we have those already mentioned hidden factors that we cannot control. It's very hard for us to control. Again, the actual number is not important. Then they could ask the question, how do we know the magic thing, the velocity? What do you do with it? If you don't keep numbers, for instance, what is about your velocity? I would say velocity per se, again, doesn't mean anything really important. Fluctuations of velocity are more important. Whether your velocity decreases or increases is something you want to be aware of, because this indicates something. Velocity per se is pointless. And then the final question from this part will be how we can use estimates to find out when will we be done with the things. Because ultimately all product financing today is based on a number that you can provide at the end. And the answer, my answer could be, well, you don't. It's pretty harsh, I could say, but you don't use estimates to indicate delivery time, because they are not useful for that. Why? Every time you estimate things, your estimate is kind of Gaussian distribution. It doesn't have to be Gaussian, it can be any other thing, but let's say Gaussian. If you estimate something to be 2, it's something between 1 and 3. That's it, kind of this. When it's 20, think about this. Yeah. It's pretty crap. Nobody knows. Yeah. Actually, if you look again at the numbers, it wasn't a mistake, of course, and I assume that you already know that this 2040 modified Fibonacci sequence was purposely emphasizing the fact that it doesn't matter anymore. At this point, whether it's 25 or 47, nobody cares. Because this mistake is so huge that you don't know what you're doing anymore. The only thing you know, actually, and we still keep the number though, we're kind of addicted to those numbers. The only thing we know when this is very big is that it's big. That's the only thing we know. We don't really know what are implications of this size, what this will change. We still keep numbers, we like numbers somehow. And actually, in many practitioners, you'll find out that they just don't use those even. Those things are equal to question marks. When you give something 20 or 40, it's like saying, I don't give a damn, actually. I don't know what this is. It's too big. And you don't want to make it small because it's still too early. Yeah? Some of the things are already small, some not. Which means, normally if you think about your sprint planning session, or maybe you have something that is often called definition of ready. And when you say this product backlog item can be considered to be taken to the sprint, so it is being kind of targeted in your sprint planning session. When estimate is 5 or more, actually, in most of the cases, I would say, it's just too big. It's already too big. So those numbers are already quite heavy. And then knowing that, knowing that your estimates are actually pretty crappy. They're only good really for your like 1 sprint, 2 sprints. When you have many teams, but we have another slide just saying don't start with many teams. But anyway, how far, knowing that your precision is so low and people still number those estimates, 20, 40, or 100, or 3,000 gummy bears, whatever things they use, yeah? What does it mean? How far to the future can you look? If you think at your product backlog, which is, let's say, deep, like this one, yeah, it's a bit of exaggeration, of course, but it's a deep product backlog. It's detailed appropriately, emergent, yeah, estimated, cool, yeah, and ordered or prioritized. All satisfy. How far to the future you can look based on your estimates. When you see already 20, it's kind of, we'll try. Which means, and it's kind of advice also, when you start with one team, you normally, in your refinement sessions, you make sure that you have 1 sprint ahead, 2 sprints ahead maximum, with product backlog items small enough so that they satisfy definition of ready. For the rest, I don't care. They maybe disappear soon. Which question could be from a question person, does it mean I should not bother estimating bigger items in the product backlog? I would say yes, forget about it. Of course, when you are Agile champion in a bigger organization, they will not let you, unless you are really champion and you are really kind of authorized and empowered to change things. You may need to keep crap, I would say. And based on that, you will probably be forced to play with those burned-on charts, which I kind of used to think they're pretty cool, but they don't say anything. Because I only know what's happening in the sprint ahead. The estimates that are coming later, they're irrelevant. This again brings this the same problem with velocity again. Yeah? To use burned-on chart, the velocity is crucial. And what are we doing? People like Mike Cohn, they actually try to find very tricky and nice algorithms to find out, oh, you should average things, take the most recent sprints into account and give a bigger weight to that so that they're more kind of indicative. Come on. But once you have 20 somewhere in your product backlog, it's already fuzzy. And many things in your product backlog will be 20 like of the size. Progress? Then people say, oh, so how do we know? Okay, I will not estimate those big things. They will be just somewhere in the product backlog. How do I know that I'm actually making progress towards some imaginary goal? Remember Ralph Stacey, we are in the context of uncertainty. Everyone influences, nobody knows the outcome. The goals are kind of very fuzzy. I'm exaggerating to some extent, but it's actually not very far from truth. You will verify your progress at every sprint. That's why it's an empirical process. That's why you don't have to worry. Scrum, an empirical process, has risk involved. But this risk, and that's the beauty of empirical processes, this risk is calculated. That's why I love this thing so much, because you can let people do bad things, but they will be verified soon. That means automatically almost we don't have to trust anyone. We see. But I'm sorry, you will not know really how much work is ahead of you. Yeah, even actually SDM2 recommends having quarterly releases. Yeah? Deadlines are good things. When you set the deadline, you know when you're done. But you don't know how much you will have. In many cases, we say, well, you can, thinking about predictability kind of your estimates and using estimates to indicate delivery time, you can ask Google, run random number generator. You can pray Jesus or talk to Oracle, whatever you like. Some of them may work. But actually if you really want to do something about your delivery and embracing Scrum to the extent you can, you have to start changing your business model. Your financing model has to start be aligned with empiricism. It cannot work anymore in the same way. And I know that people will again say, oh, but we have deadlines and everything is fixed price and we just can't. It's all the same. And it all happens mostly in corporate world, and startups do not have these problems. Yeah? And that will be, again, kind of for people that like cats, and it's in Polish, it just says, you are not dyslexic, you're just an idiot. It's kind of this, sorry, you can sit down and cry about it, but there are things you can do. And I would say what you can do, exaggerating purposely, buy the best random number generator you have at the beginning. Yeah, make it kind of gold-plated, whatever, so it looks serious, and run it in front of your business. I'm exaggerating, which means you actually have to find out your magic number, and I don't care how. Just make sure you don't waste your life and don't waste life of development team for that too much, because it doesn't matter. The number that you will find out here doesn't matter. If you will do the right job, it will not be important anymore. What you can do, second step, start small. Always with one team, whatever size of the product it is. There will be side effects, kind of funny situations, but normally this. Yeah. It's all easier. Complexity is immediately lowered, and it's so much easier to find out amount of work ahead of you. Another thing we say normally, start with walking skeleton. I even say in the slide, I say always start with walking skeleton, even if the product is already participating. Walking skeleton is kind of iteration in which you trigger initial architectural discussion. You make sure that you have time to experience how to work with different architectural parts of your system so that you get better feeling of the nature of work. Before that, before finishing it, estimating is pointless. Which basically means build predictability in your process by focusing on quality. And I say here, not only external one that everyone sees, that works or doesn't, but internal quality will be here very, very important. The internal one that says how predictable you are. Yeah, because you may start doing this and saying, okay, the business, I will convince the business, but every sprint you don't deliver, or you deliver crappy software. That will not work. They will want number again. They will not take advantage of it. You can actually do kind of standard way of doing this stuff and still invite them to participate free of charge. But you have to do quality job, otherwise it will all fail. So do it right from the beginning. Adopt, embrace engineering practices that we know are successful and we know that are helping, yeah? Like acceptance test-driven development, test-driven development, continuous integration. And then empirical process will help you on the way because your transparency is much higher and it will be all so much easier. Yeah? So instead, in other words, there's no way to predict the future, but I would prefer that people start actually be more focused on predictable delivery, and by this they can buy business into that. Yeah? It's so much more worthwhile and doesn't waste so much of your life. Okay, thank you guys.